Hello and welcome to the first class on chemical bond. We have finished periodic classification and periodic properties, and now we are heading towards the most important uh, topic of general chemistry, which is applicable in all branches of chemistry, may it be organic, may it be inorganic, may it be physical, whatever. The knowledge of bonding is important. And when we talk of bonding, we talk how two atoms they are connected with each other with some force of attraction. So that is divided into three types. One is ionic bond, covalent bond, and metallic bond. These are the real chemical bonds where there is a real handshaking. Strong, but weak bonds are also there. They are not true chemical bonds, they are physical bonds. I mean, intermolecular forces, hydrogen bonding. Under that category, you will be knowing ion dipole interaction I was talking of. And then, weaker than that, is the van der Waals forces. These are not treated as true chemical bonds. We sometimes call physical bonds because the interaction is only dipole dipole and maybe induced dipole, about which we shall be talking vividly in our uh, subsequent classes. To start with, the ionic bond is very simple. You already know, just write down. No, you will write down at home what I am saying. I will be giving you this file. Though some guys are watching the video, which I will upload very soon, those might be needing the study materials, which I am not providing, maybe because of my little, I'm not so much serious about it. And had there been any request from the side of the viewers, then I would have definitely done that. Therefore, I am only sharing the files in your batch, in your group, and not putting it in the description box as a link with the Google Drive. Uh, because my primary interest is both of you. Of course, secondary interest is if I record this for very good, promising students like you, and I can tell whatever I want, limitlessly, I can talk, then why not we record and make it public? So, ionic bond is very simple, as we learned that when the electronegativity difference between two elements is, who can tell me, is, yes, delta En, how much? That will give.
1.7.
Yes, Mr. Tripathi is correct. 1.7 or more, then the bond between these two elements will be predominantly ionic. So therefore, group 1 and 2, alkali and alkaline earth metals among the metals, and among the non-metals, group 16 and 17. I am writing in a reverse manner, 17 and 16. 1 and 17 is the most ionic because the electronegativity difference is highest. 2, 17, 1, 16, 2, 16, they have lesser electronegativity difference, but still more than 1.7. So they form predominantly ionic bond that is done by the loss of and gain of electrons, that is by ion formation. This we already know. This we already know. If it is exactly 1.7, I forgot to tell you, if delta En is exactly 1.7, then it is 50% ionic and 50% covalent. And we shall be doing how to know which has got more covalent character, although the compound is predominantly ionic, the bond is predominantly ionic. But what is the extent of covalent character? On the contrary, if it is predominantly covalent like HCl, we have seen how calculated with that crude formula, how much of ionic character or polar character it has. So all these things we'll be doing. And in earlier times when we were, of course, chemical bond is not taught nowadays in up to class 10. I don't know. In the lower stage, it is told that metal and non-metal they form ionic bond. Between non-metals, covalent bond. That also I started my programs from class 9 like that. But now a stage has come that I cannot say that ionic compound has no covalent character. And a covalent compound with two different elements has no ionic character. They have. But one character is predominant means you have to say it is predominantly ionic or predominantly covalent. And the presence of covalent character in ionic bonds that will be reflected in their properties. We will see that. We will visualize how covalent character or sharing character, not that the electrons are completely detached. And I used to funnily say that if it is completely lost, you get the cavities. As in Odia I say gatta. And when a non-metal gains electron, it becomes peaks. Bigs. Bigs means thonto. And then there is only electrostatic force of attraction, no sharing. But remember that it's not completely lost. The cavities are not 100% clean cavities, and the thontos are also not 100% clean thontos. Bigs. So there is some amount of overlapping of orbitals, some covalent character is there that makes the property affected because of the presence of that sharing nature of electron orbitals and not 100% ionic, right? You will be knowing that. Now what you have to write is factors which affect ionic bond formation. Now we know the most ionic compounds bonds are between 1 and 2 from metals, 16 and 17 and 16 from non-metals, that we know. The three different factors which influence the ionic bond formation and ionic bond strength, how strong an ionic bond is, are number one, the ionization enthalpy of the metal should be low. That is satisfied by group 1 and group 2. Group 1 is the lowest, is better, I is the least, and group 2 next to that, so that they can easily lose electrons to form positive ions in the gaseous state. And then the next point is high electron affinity of non-metals. 17 and 16, they have high electron affinities. They have the tendency, good tendency, the best tendency to devour electron and produce more energy. That is the electron affinity. So they can easily form negative ions. Halogen is better, and then 16. And then the most important is the lattice enthalpy. High lattice enthalpy is responsible to make the ionic bond strong. What is lattice enthalpy? It is the amount of energy which is liberated, always liberated or lost. It is always an exothermic process. That when 1 mole of gaseous positive ions combine with 1 mole of gaseous negative ion to form 1 mole of ionic solid. See, this is Gg, this is S solid. When they form ionic bond, they come together to form a very compact crystal. That solid crystal, during that, combination between positive and negative ions coming close together, forming ionic bond, that releases a lot of energy called lattice enthalpy. So I have given you the definition of lattice enthalpy, which will be also required in thermodynamics. L stands for lattice. This is in the standard state. 25 degrees Celsius is the standard state. Not STP. A standard state means in thermodynamics room temperature 25 degrees Celsius and 1 atmospheric pressure. It is the amount of energy evolved when 1 mole of gaseous positive ion combines with 1 mole of gaseous negative ions to form 1 mole of ionic solid. The alternative definition is the opposite. I mean, you have to break down. There is another definition of lattice enthalpy, which will be required in thermodynamics. The amount of energy absorbed by 1 mole of ionic solid to break down to produce 1 mole of gaseous ion, positive ion, and 1 mole of gaseous negative ion. In that case, this process is endothermic. You are breaking a crystal, solid crystal, into gaseous ions, in respective gaseous ions, but when you prepared crystal, solid crystal from gaseous ions, it was exothermic. So thermodynamic convention is heat evolved is negative, heat absorbed is positive. Exothermic reaction, del H, enthalpy change is negative, and endothermic, the enthalpy change is positive. And what is the actual reason? I mean, the mathematical reason which will tell you that during the formation of ionic bond, supposing you want to prepare sodium chloride, sodium is present inside kerosene, it is a solid. You have to take very carefully, cutting by a knife, you take some sodium, say 1 mole of sodium. Chlorine is a diatomic gas. Cl2 is in a cylinder. You have to take half mole of chlorine because you want to prepare 1 mole of sodium chloride solid. Half mole of chlorine gas you take very carefully, that. And then allow 1 mole 23 gram of sodium and 35.5 gram of diatomic Cl2 gas in a container. In a container, you will find automatically after some time you get common salt, NaCl. Then you stop further reaction because it will be very very fast, and you take that and give it to your mom, this is sodium chloride, you eat, you put it in my curry. Because in India, particularly in Odisha, we are fond of jholo. I don't know, in North India, they are not fond of jholo, and we take the jholo in our hand in such a unique style. Our signature style is hapudiba, khiri hapudiba, jholo hapudiba. So this hapuda, I don't think is a hallmark, is a signature mark of Northern Indians. They love roti and then some bhaji. They may take some curry, no doubt. Curry is Indian thing. They do because gravy. Why the term gravy comes? Yes, they take in very thick form of gravy, but not in such a diluted form that we drink. Almost drink. Sometimes if there is more jhol, then we take the entire container to our lip and oh, I'm so sorry. This is chemistry class. Uh, this we will be doing now. Up to this, you will write at home, right, Mr. Tripathi and Mr. Mahanti?
Yes, sir.
Up to this. Oh, এটা নো, এটা কাই বার করলে, এটা কি দরকার নেই। Where's this one? Up to this. Definition, lattice enthalpy. These are the three factors. More the lattice energy, stronger is the bond. It লেখা আছে। এইটি ଗୋଟେ କୋଉଠି ଲେଖା ହେଇଥିବ, এইটি। High lattice enthalpy. That means higher the lattice enthalpy of the chemical bond, of the ionic bond, stronger is the ionic bond. Now let's see how in any kind of bond formation there is lowering of energy. There is a net lowering of energy. So that we will be doing here. net lowering of energy during ionic bond formation. सेमती आम कोवलेंट बॉन्ड फॉर्मेशन भी पढ़ा. That will be explained through a very typical cycle called Born-Haber cycle. This is based on a thermodynamic law called Hess's law. Let me write down that law, although we'll be formally, officially studying in thermodynamics. But Hess's law states that the net heat change or enthalpy change remains unchanged whether a reaction is carried out in one step or in several steps or multiple steps. If you carry out the reaction in one step, whatever energy change, whatever heat change will happen, same will happen if we carry out the same reaction in multiple steps. This is the essence of the Hess's law of thermodynamics. Now, let's play Born-Haber cycle. Supposing you take 1 mole of sodium and half mole of chlorine gas and directly put it in a calorimeter. Make the reaction in a calorimeter which will record the temperature change, and you can find out the Q is equal to ms delta T. S is the specific gravity, specific heat capacity of that particular substance, the calorimeter, and then delta T you measure from thermometer. You know what is the amount of heat evolved. It will be heated up. So NaCl 1 mole solid will be prepared, and plus minus we forget, but must give plus. This is the heat. This heat is called the heat of reaction. Heat of, in this case, we can call it heat of formation. For any reaction, it is called heat of reaction R. But this, when the particular compound is formed from the corresponding elements in their standard states, chlorine is a diatomic gas and sodium is a solid. So these are the standard states, and whatever enthalpy change happens, this is an exothermic process, but some processes are endothermic. So delta will be here, but here now this is exothermic, delta will be here. So when such a thing happens, then that heat of reaction has a special name called heat of formation. Okay. And supposing we don't do it in one go, just add the two and get the answer. We do stepwise for fun. For fun, we can do sodium solid. Let us give the ionization enthalpy, which is positive, so that it will become no. First, you have to vaporize sublimation enthalpy. Which is roughly equal to the sum of molar heat of fusion plus molar heat of vaporization, roughly equal to. Because when you melt it at melting point without change of temperature, you supply some energy. And then from melting point to boiling point, also you have to supply some energy. But that may be neglected. And then when it boils to the vapor phase, that is the molar heat of vaporization, as we sometimes call latent heat of vaporization. So that sublimation energy, that is positive. It is absorbed. Then it produces Nag. Then you take Nag, supply ionization enthalpy, so that you knock out one electron to convert it to sodium ion gas. And on the other side, say this three steps, two steps, uh, Swam has done. He has 1 mole of gaseous sodium ion. Now what Mr. Tripathi will do, Bismay, now he will chop up the covalent bond. That is called the bond dissociation energy. So since there is half mole, half bond dissociation energy. BD stands for bond dissociation energy or bond energy. That is for definition for 1 mole of bonds. Since we have half mole, and therefore the number of moles of bonds will be also half moles. So he will be producing, and that is also positive. So there are how many positive terms involved now? Swam, all the two positive, chlorine, and here Bisma, one positive. And then when it becomes chlorine atom, then you feed these electrons, which Swam has collected these electrons so that they will be evolving, they will be converted to negative ions and releasing energy, the electron affinity, which is negative. This becomes chloride ion gas. Then you combine, take 1 mole of sodium ion gas from Swam and take 1 mole of chloride ion gas from Bismay. Say another guy will be given the task of uniting them. You will find within no time they will produce 22.4 liters. 22.4 liters, I'm talking of STP condition, just for fun. They will give you solid of this. I mentioned sodium chloride, the density, supposing it is having no, we'll be talking in that solid state. A lot of defects are there in crystal, sodium chloride crystal, the Schottky defect that makes the density so low that sometimes it floats, it dissolves, but it should be heavy if it is having no defect. Supposing it is 1, supposing it is 1, then sodium chloride 58.5 gram, sorry, 58.5 gram is 58.5 cc in this much. 22.4 liters plus 22.4 liters will be crumbled, will be just squeezed, will be contracted to only ionic crystals of such small volume, 58.5 cmq. I'm just taking sodium chloride, a defective sample of sodium chloride, as density is very close to 1. But if it is a single crystal having no defect, it is really heavy. It can be 2, 3, 4. So this is called the lattice enthalpy, LE, which is hugely negative. So according to the Hess's law, the this in one step, this is the one step process. Whether you carry out in one step or in several steps, the sum will be same. Now these are, you have to add up sublimation energy, which is positive, ionization enthalpy, which is positive. Automatically, when you solve the problem, you will be putting the positive value. And on the other side, half bond dissociation energy, this will be also positive. And then electron affinity will be automatically negative. Then lattice enthalpy, which will be hugely negative. And this is equal to the sum of 1, 2, 3, 4, 5 energy terms. 1, 2 here, 1, 2 here, and the third is here. So altogether 5 energy terms are involved to arrive at the same product that we had done in only one step. Without understanding what really steps can be, we just added up all those steps, supposing you mentally imagine have happened together. Of course, there is no gas formation. It all happens together in one step. But you conceive, supposing one gas formation happens, sodium is sublimed, is sublimated to form vapors, then you pluck out an electron to give sodium ion, then chlorine bond is, Cl-Cl bond is chopped off, chlorine atoms are formed, then feed electrons to get chloride ion, and then add the two ions, gaseous ions, and then get the crystal. So that all these 5 energy terms you add, you will find same. Now here I have given you a problem. Same thing I have written. Well, I will give you a problem. which all these but one. Actually, lattice enthalpy is determined by this method. Is all other energy terms are experimentally determined. Bond dissociation energy, electron affinity, sublimation energy, ionization enthalpy, and the net reaction in a calorimeter you can find out in one step process. The lattice enthalpy cannot be determined experimentally. So by using this SS law or Born-Haber cycle, we determine this lattice enthalpy. You understood? So I will give you a problem giving all 6 out of the 6. I will give you 5 data. So you will have to find what is the lattice enthalpy of sodium chloride formation when sublimation energy of sodium is this much. The ionization enthalpy of sodium G is this much. The electron affinity of chlorine G is this much. The bond dissociation energy of chlorine molecule CL-Cl bond is this much. You have to have it. Bond dissociation energy will be coming per mole, but here we need half. And then find out what is, and the net reaction, one step reaction, what is the enthalpy change, the enthalpy of the reaction in one step lekhai nathibo. You understand the enthalpy of formation. In this case, it is enthalpy of formation. May not be always the case. It may be any ionic crystal is produced from. Most of the time, it is enthalpy of formation. Elements in their standard states. Standard state. Sodium is a solid, started from solid. Chlorine is a diatomic gas. That is the standard state. So that heat change in one step is called the enthalpy of formation that we'll be doing in thermodynamics. Now we will be doing the Lewis structure. It's very simple. Supposing we'll take sodium plus chlorine giving you NaCl. How to represent? It's very simple. Sodium is 3s1. Neon configuration 3s1. Chlorine is neon configuration 3s2, 3p5. So you know, so sodium Na and there is only one unpaired electron. Show it as one dot. Chlorine has 3 lone pairs. You already know, poly, poly. 3 lone pairs. And 1 unpaired electron. So only take the valence shell and determine the number of lone pairs. So the lone pairs in a manner placing the dots close to each other so that anybody can understand that these are lone pairs and this is an unpaired electron, and put a different symbol. Supposing this is cross, this is dot. Although electrons are same, but to show the Lewis structure, we give a different symbol for electron for different elements. And what happens? This having lower ionization enthalpy, this having higher electron gain enthalpy. Here I am telling the correct thermodynamics term. So automatic there will be a transference of electron. Na will be converted to Na plus, and it will be having a neon configuration, octet configuration. And as we always say that every chemical bond formation, the driving force is to attain the nearest noble gas configuration, octet or duplet configuration. That is the driving force for bond formation. So I have written when I started, I didn't tell you that, but when I start in a normal class, I used to say the first is what is the driving force must be written. No, not written. But in other classes, I say what is the driving force? There is a chemical union. It is because every element has a strong tendency by hook or by crook to attain the noble gas configuration, either by losing and gaining electron if they have a lower ionization enthalpy for metals and higher electron affinity for non-metals to form ions, or by sharing. Whatever is the means, they have to stabilize themselves by forming bond so that they will attain the nearest noble gas octet or duplet configuration. But this is not the nowadays, this is not the only requirement. Yes, this is one of the requirements, but even if you will find the octet configuration is not maintained, still the bond is formed. We will take umpteen number of cases where octet configuration doesn't happen, but still there is bond formation. I will tell you, well, 6 electrons, 4 electrons, they share, particularly in covalent compounds. You will not find the atoms will enjoy octet configuration, but still they are stable. PCl5. Phosphorus enjoys 10 electrons during the covalent bonding between 5 chlorine atoms. Each covalent bond has 2 electrons, so 5 2s are 10. Still PCl5 is stable. BF3, these are the 3 covalent bonds with the 2, 2, 2, 6 electrons. There is no lone pair, so even if that is stable BF3. So earlier it was thought that it is the only and only criterion for chemical bond formation, but now, yes, this is one of the conditions, but the definition has changed. Chemical union or chemical bonding happens to bring about a net lowering of energy during bond formation, net lowering of energy so that a stable compound is formed, either by the attainment of octet configuration or duplet configuration or not. Stable compounds ଯଦି ହେଲା କୌଣସି battery energy loss ହେଲା, stable compound ହେଲା, then that will be the driving force. So ସେଇଟା ଗୋଟେ କୋଉଠି କୌଣସି ଗୋଟେ ଲେକ୍ଚରରେ ମୋର ଅଛି, ମୁଁ ଦେଇଦେବି ତମକୁ. Now see, sodium ion ହେଇଗଲା ଏଠି, ଏଠି କ୍ଲୋରାଇଡ୍ ଏମିତି ଲେଖିବ डॉट छकी छकीटा आसीगला एटिकी, सो एटा हेगला क्लोराइड आयन. माइनस टा एटी देले खराब लागुची, दे देले हबो ऊपर देलो. एंड दीज टू आयन्स, पॉजिटिव एंड नेगेटिव आयन्स being opposite in charge, so they will have strong attraction between them. You can show in a different color. This strong attractive force make them come together very close to each other as if they are side by side, and they form ionic bond. This is this force of attraction that forms the ionic bond. And the net amount of energy released we have already seen in the Born-Haber cycle, and that is the enthalpy of formation, one step, which can be indirectly calculated by adding all these 5 energy terms. Similarly, you can say, supposing calcium oxide, calcium atom and oxygen atom, all the gaseous state will form. Calcium is, argon configuration 4s2, and this is 2s2, helium configuration 2s2, 2p4. So this will be having a lone pair, and this will be having 2 2. 2 lone pairs and 2 unpaired electrons. You can show the box. So show the unpaired electrons in a manner that everybody can feel that they're not together. So that what happens, oh, sorry, choki, I'm so sorry. Now what happens when they combine to form bond, this electron supposing comes here, this electron comes here, so the calcium becomes a divalent positive ion gas, and there will be a formation of choki, and choki dot, so that it becomes 2 minus. So there is a huge attraction between these ions to form. These are called the Lewis structures. Similarly, if you take potassium oxide, oxygen will be at the middle and 2 potassium at the 2 sides. Each potassium is 4s1. Argon configuration for oxygen is a helium configuration 2s2, 2p4, 2, 2. So it will be 2, 2 and 1 here, 1 here. Potassium will be 1, 1 each, so that the metals will give, and then potassium will be potassium ion, and in the middle it will be oxide ion, chalky dot, and it will be 2 minus, and here also K plus. So there will be huge attraction on either side, and it will, this is the ionic bond formation. Similarly, at home, you will do for, say, magnesium chloride, where you put magnesium at the middle and chlorine atoms at the two sides. Magnesium will lose electron, one to this, one to that. Show them in the form of lone pairs and unpaired electrons. You can say, you can make a cesium bromide. You can make for mm, mm, strontium bromide, say strontium fluoride. You can also make for magnesium sulfide, although it has some more covalent character. But I want to see its ionic bond Lewis structure. Well, magnesium oxide तो हमें करिछे, sulfide रो गोटे करिबा. So let it be sodium sulfide. Okay, we thus finish our program, and this slide which I have brought is finished. I'll send you. That I do in one class. So this is the Hess's law. I have shown it in pictorial form. If this is a single step process, R stands for reaction. In this case, it is heat of formation, but in general, this is one step process, and this is multiple steps process. Del H1, del H2, del H3. And the sum of all these steps will be equal to the single step process. And this, you have done it. Lewis structure, you have done it. And next time we shall study how covalent character in ionic compounds can be related with different compounds by using Fajans rule. Many ionic compounds have some covalent character, although are predominantly ionic. Supposing beryllium fluoride, beryllium oxide, which are strongly ionic, but all other beryllium compounds are predominantly covalent. Beryllium chloride is declared as a covalent compound, but beryllium is group 2, chlorine is group 17. ये क्या है? Lithium compounds have appreciable covalent character, but with group 16 and 17, it is predominantly ionic, but appreciable. For example, lithium iodide is such a compound having 50% ionic and 50% covalent. These are explained by Fajans rule. So we'll be talking about Fajans rule and all this in our next class. And we sit on, today is August 15, Independence Day. And unfortunately, we observe Janmashtami. Those who profess Hindu religion and their followers of deities, Krishna, they have their own agenda today. I mean, puja, not agenda. Some people, they go for fasting. The whole, I mean, waterless fasting, nirjala upavas. Some people eat puri, rasagulla, and sweets, but they say they do fasting. And some people declare that they will say eat only बिना पियाज रसुण और खाइबे पूरी फूरी खाइबे किंतु अन्न खाइबेनी अन्नरे कौन दोष अच्छी के जाने आई डोंट नो से पूरी फूरी करती खाते you know today I have to go to hoist the flag of our colony. Our colony, which is called Friends Colony, there's a tradition for so many years to have a flag hoisting, not hosting program. And the president of that colony is, on the basis of protocol, does that. This time, I have to do that. So I have planned to tell a story. What is independence? Just to commemorate the sacrifice of the soldiers who brought and the freedom fighters who brought independence to our nation long ago, 78 years before. This is the 78th Independence Day that we are observing today. Yes, but this formality is going on, meaningless formality is going on, hundreds of lakhs of rupees, maybe crores, I can dare say, is being wasted in every state and in the nation for just for nothing. What independence we have brought? What is the independence of the main independence that we enjoy? We don't enjoy any independence. We are not independent in our mind. Independent means free mind. Our minds are not free, is being completely overburdened with the societal influences, which is mostly the feeling of me and mine, not others, not each child. It is my child, not me, not you, but me. This kind of narrow thinking we are nurturing in our minds. And I'm not saying all. I definitely would like to tell a story there that one person was in the night, was trying to sail a boat from one place to the other place to his village. He boarded the boat. It was a stormy, not stormy, windy night, and the river was flowing with good pace. And he sat in the boat and he thought, because he was probably drowsy, he thought the boat is going. He is going. Then he slept. He was so drowsy, he slept. When he woke up, maybe in the morning, he found himself in the same place where he started. Why? Because the boat was tired. It was tired. In the seashore, there is a bamboo where it is tied. Always it is tied. So if we remain, tied, TIED, with some belief system, ବାପା କହିଛନ୍ତି ମା କହିଛି ହେ ମାଡ଼ ମାର ମୁଣ୍ଡିଆ. This is the gospel truth, and you don't go away from that dogmas. Maybe some of them are dogmas, and some of them are superstitious. You don't go away and see and fly like a bird in the sky and become free in mind. Unless you become free in mind, you cannot get the bliss. Paramananda, blissful state can only be achieved if your mind will be free and independent. Then only you will become fearless. All of us are afraid of everything. କି କାଳେ ମାରିଦେବ, ତାକୁ ଏମିତି କହିଦେଲେ କାଳେ ସିଏ କ'ଣ ଭାବିବ, କାଳେ ମତେ ବାଡ଼େଇବ, ମୋ ପିଲାକୁ ବାଡ଼େଇବ. ଇଭେନ୍ ଭଲ ଲୋକକୁ ମଧ୍ୟ ଆମେ କିଛି କହୁନୁ. ସେ ଯାହା କହୁଛି ହଁ କୁ ହଁ ମାରିଦେଇକି ଆମ କାମ ଚଲେଇଛୁ. The whole life will be lost, wasted by not changing to attain independence, independent mind, free mind, which will bring us the bliss, ananda, which will, I'm talking of scientific things, not any spiritual, which will bring us the real bliss. Real bliss, the is that bliss which is causeless. କାହିଁକି ଯେ ପଚାରିବ କାହିଁକି ଏତେ ଖୁସି ଖୁସି ଏତେ ଏତେ ଆନନ୍ଦିତ କ'ଣ ପାଇଁ I don't know, but bliss. And then you become fearless, ନିର୍ଭୀକ. Not that ନିର୍ଭୀକ ହେଇ କାହାକୁ ବାଡ଼େଇବ, ନିର୍ଭୀକ ହେଇକି ତମ ମତ ପ୍ରକାଶ କରିପାରିବ. And you gain the real knowledge. And then the buy two get one free. The free is compassion. କରୁଣା ମନକୁ ମନ ଝରିବ. କରୁଣା ଯୋଉ ଜିନିଷଟା ଜଣକୁ କ୍ଷମା ଦେବା, ଜଣକୁ ହେଲ୍ପ କରିବା, ସେ ଜିନିଷଟା ତ it is spontaneous. It is not manufactured in any factory. Okay, bye bye. ମୁଁ ଟିକେ ପ୍ରାକ୍ଟିସ କରିଦେଲି, ରିହର୍ସଲ କରିଦେଲି.
Thank you so much.
सर
କ'ଣ କହୁଛ?
सर
ହଁ,
सर जो पुराना जो सर पढ़ा ହେଲା सर जो नेचर ऑफ ऑक्साइड सर सेଗୁଡ଼ା ପଠେଇବେ।
ହଁ ପଠେଇବି ଯେ ଟିକେ ଡେରି ହବ ଆଜି। ମୁଁ ଡେରି ହେଲାଣି, ମୁଁ ଟିକେ ଟେମ୍ପଲ ଯିବି, ଡେରି ହେଲାଣି। ମୋତେ ଟିକେ ମନେ ପକାଉଥିବ। ମୁଁ ବି 8:15 ପରେ ସେଠିକି ଯିବି। ତାପରେ ମୁଁ ଫ୍ରି ହେବି 10ଟାରେ। 10ଟା ପରେ ମୋତେ ମନେ ପକାଇବ, ସାର୍ ମ୍ୟାଟେରିଆଲଟା ପଠାନ୍ତୁ, ହେଲା। ମୁଁ
ଆଜ୍ଞା ସାର୍।
ଅପଲୋଡ଼ ବି କରିବିନି, ସେଟା ରେକର୍ଡିଂ ହେଇକି ରହିଯିବ, ମୁଁ ଅପଲୋଡ଼ ବି କରିବିନି। ବାଏ ବାଏ।